Hello guys, how are you today? So today I'll be explaining the remaining of the top questions on CQDs. So let's start with CQD 11. Consider the curve C whose equation is fx equals minus 1 over 8x squared minus 65. What is the value of b? If y equals ax plus b is the equation of the normal to c at x being 1. First thing we need to do, we can't have x being a always x needs to be with y. So how do we find the y of this x? We just need to substitute x over here. So it's gonna be minus 1 over 8 times 1 squared minus 65, and we will get the value of our y to be what? To be 8. Now we need to find the value of the slope of the original slope. Let us find the value of the original slope. Very simply, we need to take the derivative. So when we take the derivative, it becomes minus 1 over 8 times 2x, right? And we know that our x is what? Our x is 1. So it becomes minus 1 over 8 times 2 times 1. So the slope, the original slope, is minus 1 over 4. How do we find from the original slope the normal slope? Very simply, you will do minus 1 divided by minus 1 over 4. So that's going to be what? That's going to be 4. Now we have what? We have the slope of the normal. So y equal 4x plus b. We have x to be 1. We have y to be 8. So now that leaves us with b being equal to what? B being equal to 4. And just like that, we found the value of b. Let's move on to 12th grade. A curve has equation y equals x squared minus 4x plus 20, and the line has equation y equal 2x plus a, where a is constant. Show that the coordinates, the x coordinates of the points of intersection of the line and the curve are given by the equation x squared minus 6x plus 20 minus a. So a curve has this equation, okay. Show that the x coordinates of the points of intersection of the line and the curve are given by this equation. So very simply, the intersection equation is gonna be curve minus line. So it's gonna be x squared minus 4x plus 20 minus 2x plus a. So basically minus 2x minus a, right? So then it will be x squared minus 6x plus 20 minus a. Perfect. Now, they said, okay, part B. For the case where the line intersects the curve at 2 points, it's given that the x-coordinate of one of the points is this. So, what was our answer in part A? It was basically this. They said that one of the points of intersection is minus 4. Using this information, we can find the value of A. That means, if it's a point of intersection, then it's also a root. That means minus 4 squared minus 6 times minus 4 plus 20 minus A is equal to what? Is equal to 0. So, after solving, we will get what? We will get that A is 60. Now that we have the value of A, we'll be able to find the other point of intersection. So x squared minus 6x plus 20 minus 60. So that's going to be minus 40. Just put it on the calculator mode, 5, 3. That's going to be 1, minus 6, and minus 40. So that's going to give us two possible values, which are 10 and minus 4. Perfect. Now we have the second value, which is 10. Part C. For the case where the line is tangent to the curve at point P, find the value of A and the coordinates of. Now, whenever we're dealing with a tangent, the discriminant needs to be equal to 0. That means b squared minus 4ac needs to be equal to 0. So minus 6 squared minus 4 times 1 times 20 minus a is equal to 0. So 36 minus 80 plus 4a is equal to 0. What is 36 minus 80? That's going to be minus 44. Minus 44 plus 4a is equal to 0. 4a is equal to 44. That means a is then equal to 11. So now we have the value of a. How do we find the coordinates of p? We very simply need to find the roots. So it's going to be minus b, so minus 6 plus minus radical 0 over what? Over 2 times 1. So it's going to be what? It's going to be 6 over 2, which is 3. So we have x to be 3. What about y? You need to substitute it in the original equation, which was what? Which will be here. So we need to substitute it into this equation over here. So it would be what? It would be 17. That's it for question number 12. Let's move on to the next question. I think we have page 13 to 14, question 17, 18, and 19 all the way to 25. So 17, 18, 19 all the way to 25. Hopefully I'll be able to finish them this video. And then we have what? We have 7, 10, 11, 12, page 18. Where is page 18? Okay. Let us see then. We'll go back to where we were. So now we have question number 7. They want us to find f prime 3. So first of all, we need to find the derivative of this. Let us take the derivative of this. So it's going to be 24 times x to the power of 3 minus 11 to the power of half. Now what do? We need to apply the chain rule. So 24 times half x to the power of 3 minus 11 to the power of minus half multiplied by what? Multiplied by 3x squared, right? So this will become 3 over 2x squared. Perfect. So now it will be 24 times 3 over 2. That's going to be 36. So 36x squared over what? Over radical x to the power of 3 minus 11. So that's going to be what? That's going to be easier for us to solve. You just need to now substitute x by 3. So it's going to be 36 times 3 squared over radical 3 to the power of 3 minus 11. And we will get the answer to be what? To be 81. Honestly, I'm not going to solve 18 because it's the same exact concept. You guys just need to know how to solve it. We move on to question number 19. Find the gradient of the curve y equals this at the point where x is 3. So how do you find the gradient? You need to take the derivative first of all. So I prefer to move this up. It would then be 9 times x squared minus 4x to the power of minus 1. So 9 times minus 1 x squared minus 4x to the power of minus 2. Take the derivative of the inside. So that's going to be 2x minus 4. So then that's minus 9 times 2x minus 4 over x squared minus 4x squared, right? So that would be minus 18x plus 36. Now, the gradient is at which point? The gradient is at point 3, so we need to substitute x by 3. And when we did substitute x by 3, what would we get as an answer? We would get our answer to be minus 2. Okay, 20 top. A curve has the equation y equals k over x. Given that the gradient of the curve is minus 1 when x is equal to 4, find the value of constant k. So they said the gradient of the curve is minus 1 when x is 4. That means we need to take the gradient of this. This is k over x, right? We can take it as k, because k is like a whole number, times x to the power of minus 1. So k times minus 1 x to the power of minus 2. So minus k over x squared, right? So this is the derivative, minus k over x squared. They told us that x was x was 4. It will give us an answer of minus 1. So move this up. It will be minus k is equal to minus 1 times 16. So minus 16. That means k is how much? K is going to be 16. We move on to 21 top. A curve has the equation y equals 2x to the power of 3 minus 2x squared plus 5x plus 8. Show that the gradient of the curve is never negative. So let's take the derivative to find the slope. It will be 6x squared minus 4x plus 5. So let us find the roots by using discriminant, b squared minus 4ac. So it's going to be minus 4 squared minus 4 times 6 times 5. So put it on the calculator and you will get minus 104. Because it is negative means that that a is what it's going to be greater than 0. What does that mean? That means the slope, the gradient, can never ever be negative. We move on to question number 2. The diagram below shows part of the curve y equals 3 minus 15 over 2x plus 3, which crosses the x-axis at A and the y-axis at B. The normal to the curve at A crosses the y-axis at C. Show the equation of the line of AC is 5x plus 6y equals to 5. So AC, 5x plus 6y equals 5. Okay, so what we have over here? We have the equation of the curve. They told us that they want us to find the equation of the line AC, so y equal mx plus b. How do we find the slope from this? We know that A is a point on AC, right? And it crosses the x-axis. When it crosses the x-axis, that means y is 0. So 0 equals mx plus b. If that's the scenario, we will need to find the value of x. How do we find the value of x if we have y? So 0 is equal to 3 minus 15 over 2x plus 3. Definitely, after solving it, you're going to get the value of x, which is what? Which is 1. Now, how do we get the slope? Very simply, to get the slope, you'll need to take the derivative. So it's going to be what? I think I'm going to leave the derivative for you guys to do it. It's going to be 30 over 2 times 1 plus 3 squared, right? So if you simplify it, it's going to be what? It's going to be 6 over 5. So this is the value of our slope, 6 over 5. Now we can find the value of b. 0 is equal to 6 over 5 times 1. That means b is what? B is, oh, sorry, my bad. The 6 over 5 is what? The 6 over 5 is for the tangent. Now, how do you get the normal? You're going to do minus 1 divided by 6 over 5. So that's going to be minus 5 over 6. So now the slope is what? The slope is minus 5 over 6. So minus 5 over 6 times 1 plus b is going to be 0. That means what is the value of b? It's going to be very simply plus 5 over 6. Now you can change these back into y and x and you can solve. No, I lost it. My bad. Let me write it again. It was y equal minus 5 over 6, x plus 5 over 6, right? Now we just need to solve it. How do we solve it? We get rid of the 6 in the denominator, so it becomes 6y equals minus 5x plus 5. Move this to the other side, it becomes 5x plus 6y equals 5. Now, we need to find the length of BC. We have the length of AC, right? But actually, we don't need anything. We just need to find the length of BC. That means we need to find the point B and the point C. We first start very easily with the point B. We know that it's intersecting the y-axis. That means x is 0. Same exact thing with C, by the way. So if it's intersecting 0, how do we find the y? You just substitute it in this equation over here. So 3 minus 15 over 2 times 0 plus 3. That's going to give you an answer of minus 2. Now, how do you find the y of CC? We know the equation of its line, right? So we can just substitute it over here directly. So y is going to be minus 5 over 6 times 0 plus 5 over 6. So y is going to be what? It's going to be 5 over 6. Okay, now what do we need to do? We need to do the equation for the length or the distance, which is radical a plus a squared, so x plus x squared, minus, or no, I switched them up, my bad. It's x minus x squared plus y minus y squared, so plus minus 2 minus 5 over 6 squared. So you will put it on the calculator and you're supposed to get an answer of 17 over 6. We move on to 23 top. A curve has the equation y equal 10 over 3x. Point. Oh, did we take about the angle? No, but I doubt it would be that hard to find the angle. Okay, this is important. A curve has equation y equal 10 over 3x minus 4 and P32 is a point on the curve. Find the equation of the tangent to the curve at point P. In order to do that, because it's a straight line, we need to do y equals mx plus b. We have the point, which is 3, 2. We have x and y. The only thing we need to find is the slope. How do we find the slope? We take the derivative of this. After much practice, you're supposed to get it as minus 30 over 3x minus 4 squared. So how do you find the slope of the tangent? You just substitute x in here. So when you do substitute x in here, you are supposed to get an answer of minus 6 over 5. So now we have the value of m. y equals minus 6 over 5x plus b. How do we find b? By substituting x and y. So after substituting x and y, you will get the value of b to be 28 over 5. Now, the angle that the tangent makes with the x-axis is very simply what? It's very simply tangent inverse the value of the slope, which is minus 6 over 5. Actually, you can take this from physics. Do you know how to find theta? It's tan inverse y over x. The slope is y minus y over x minus x. So tangent inverse minus 6 over 5 is basically tangent inverse y over x, which will give us our angle to be approximately 129.8 degrees. Question 24 top. The equation of a curve y equals 7 minus 9 over x. Show that the equation of the normal to the curve is this. The normal meets the curve again. Okay, we already solved something similar to 24. I'm gonna leave it for you guys. Okay, 25 we already did exactly like the same. However, to find the midpoints, you just need to take what? You just need to take the two x's, add them together, divide by 2. And then the two y's, add them together, and then divide by 2. And this is how you will have your midpoint. So I'm not gonna waste my time on these. Now we have in page 18, 7, 10, 11, and 12. 7, 10, 11, and 12. Okay, let's see. A curve has this equation. Find the derivative of this. Okay, after many practice, you're supposed to have it at least like, you're supposed to have it at least practiced. So it's gonna be what? It's gonna be 18 over 4 minus 3x squared, okay? Now, point moving along this curve as the point passes through point A, the x coordinate is increasing at a rate of 0.9 units per second, so that 0.9 is equal to dx over dt, okay? And then the y coordinate is increasing at 0.2 units per second. That means dy over dt is 0.2. What does that mean? So now, what equation can we make out of this? We know that dy over dt is equal to dx over dt. How do I change dx over dt into dy over dt? Very simply, I multiply it by dy over dx. That means I take dx over dt, which I have to be 0.9. I multiply it by 18 over 4 minus 3x squared, right? And then I will make it equal to what? I'll make it equal to 0.2. Now, you can bring 0.9 to the other side. It's 18 now over 4 minus 3x squared is equal to 2 over 9. You can do the crisscross method. So, you would get 81. Or sorry, not 81. 9 times 18 is 162. 162 is equal to 2 times 4 minus 36 minus 3x squared, right? Now divide both sides by 2. When you do that, you're going to get 81 is equal to 4 minus 3x squared. Now, what do? You do radical here and radical here. So you have plus minus 9 is equal to 4 minus 3x. So that means x can be either equal to minus 5 over 3 or 13 over 3. That's it for 7. We move on to 10. Okay. They want the point of inflection. How do you find the point of inflection? You need to do the double derivative. So the first derivative is going to be 5x squared plus 50x minus 48. The second derivative is going to be 10x plus 50. That means x is going to be equal to minus 5. So this is the point of inflection. Pretty much it. 11. Function f is defined by this. I think we solved something like this similar in the quiz, right? So they want the values of r and c. R are the roots, and we know that roots r times r, and r plus r, 3r plus r, is equal to what? The roots multiplied to each other is c over a. The roots added to each other is minus b over a. So we start with added to each other because we have the value of b. So it's 4r is equal to minus b over a. So that's going to be 4 over a. That means a is 1 as well. That means r is equal to what? R is equal to 1. So because r is equal to 1, we'll just replace it by 1. That means it's going to be 1 times 3 times 1, which is basically what? Which is basically 3. Now, 3 is equal to c over a, right? C, we need to find it. A is 1. That means C is equal to 3. That means R is equal to 3, right? And, sorry, R is equal to 1, my bad. And C is equal to 3. Now, they want us to write fx in factored form. So, it's x squared minus 4x plus 3. We need to make it into factored form. It will become x minus 1, x minus 3. Now the coordinates of the turning point of graph f. So when they say turning point, I think they mean like point of inflection. So we'll need to take the double derivative. So we take the first derivative, which is 2x minus 4. And then we take the second derivative, which is what? Which is 2. That means the point of inflection is what? Is 2. Okay, question number 12. Consider this function over here. Use the chain rule to get the derivative. So it's going to be 4 times x squared minus x minus 12 to the power of 3. Don't forget to multiply by the derivative of what's inside. So 2x minus 1, right? So now, after expanding it, actually no need to expand it more. This is it. So find the coordinates of any stationary points. Now what do you need to do? Just multiply by 4 over here. It will become 8x minus 4. And here you need to factorize it. How do you factorize what's inside? You just factorize it, right? So it's gonna be x minus 4 and x plus 3. Now what does that mean? That means we have 1, 2, 3 stationary points. Let us see. The first point we have is gonna be x is equal to 4. Second point, x is equal to minus 3. And the last point is gonna be x is equal to half. Perfect. Now, we found the stationary points. Let's determine their natures by doing the table of variation, right? So let's do the table of variation. We start with minus 3, then half, then 4. Choose a number smaller, for example, minus 5. In between, for example, minus 1. Greater, or like in between half and 4, we can choose 1. And greater than 4, we can choose 5. So if you substitute minus 5 in this equation over here, you will get a negative number. If you substitute minus 1, you will get a positive number. If you substitute 1, you will get a negative number. And if you substitute 5, you will get a positive number. So down, up, down, up. That means we have a local minimum at minus 3 and 4 and a local maximum at half. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.